Welcome to ChemVid. Today we're going to talk about how to take another average. So you already know one way to take an average, where you add them all up and divide by one number. This way is a little bit different. So first, let's start off by defining average atomic mass. The average atomic mass is something that is made up of multiple things. An average means that you are taking multiple measurements and putting them together. We have learned about isotopes. Isotopes are what we call the variations of one element with different neutrons. So for instance, I can have chromium. Chromium, if I look at the periodic table, has 24 protons. Okay? All chromiums have the exact same amount of protons. Every single one of them, no matter what, because protons give the identity to the atom. However, they can have different masses, and that's because of the neutrons. So if I look over here, here are the four isotopes of chromium. Chromium 50, chromium 52, chromium 53, and chromium 54. So if I want to know how many neutrons a chromium has, I take the mass number, I subtract the 24, and I get 26 neutrons. Again, 52, subtract 28 neutrons. And so on and so forth until I find out that they all have a different amount of neutrons. And that's what we call an isotope, is the different masses of the same atom. So when we define average atomic mass, it's basically taking the mass of all of the different isotopes I have and finding out what the average is, or how much each atom gives to the total average mass. Now in this case, if I had 4 chromium isotopes, I could just take these isotopes and take their mass, 50 plus 52 plus 53, oops, I forgot 50, plus 53, plus 54, add those all together and then divide by 4, and that would give me an average. 52.25 AMU. AMU is the unit we use for mass of an atom. So that's how I can find an average. However, thinking about it, exactly how many isotopes are there? Well, we know there's 4 of them, but how many chromium atoms are there in this world? Billions and billions and billions and billions and billions. Alright? Way too many. We can't add them all up and divide by the total amount. So that's why we are learning a new way to take an average, which is done by percent abundance. So the average atomic mass is the average mass of the isotopes of a single atom. Average mass of the isotopes. And the way we find this is not by doing the original way that we've all known to come and know and love, but by taking it a new way, using the percent abundance. So what happens is we take a sample of chromium, okay, just a random sample, and it's filled with all of the chromium isotopes. These chromium isotopes are then put into a machine, we call it a mass spectrometer, and that machine tells us how many of each isotope we have. We call it a mass spec, I guess we can put it that way. And once I know how much of each isotope I have, I can find the average atomic mass. So in my mass spectrometer told me that 4.3% of all chromium atoms are chromium 50 isotopes. All 83.79% of all chromium atoms are chromium 52 isotopes. 9.5% is 53, and 2.36% is 54. Okay? So that's what this information means. And I know that percentage just means out of 100. So the first thing that I'm going to do is I'm going to take these percent abundances and I'm going to turn them into numbers for math, okay? So a percentage is times 100, so I'm going to take this and it's going to be 0.001. 0.0435. If you don't know how I did that, I take 4.35% and I divide by 100 to get the regular number. Because percentage just means multiplied by 100. So if I took 0.0435 times 100, that gives me 4.35. Okay? So all the ones I want to do, I'm going to take all of these and I'm going to divide by 100. Alright, now that I have turned them back into real numbers, they are no longer percent abundances, they're just numbers, I'm going to take the mass of my chromium-50 isotope and I'm going to multiply it by the abundance. We're going to take the mass of my 52 isotope and multiply it by the percent abundance. Multiply my 53 and my 54 by their respective percent abundances. And I'm going to get how much mass comes from each isotope. Alright, so again what I did is I took my percent abundance, 0.0435, times 49.946, and I got 2.1726. What these numbers tell me right here is they're telling me how much of the average mass is made up from a given isotope. So for instance, chromium-52 makes up 45 grams of the total average mass. So if these are all pieces of the average, all I have to do is add these together. And when I add them together, I get the overall average atomic mass, which is 53.996. So, right now, if I took a chromium sample, the average mass of a chromium atom is 53.996. Do I need to divide this by 4? No. Do not divide by 4. Do not. No. Okay? What you have done by doing the percent abundance is you have already taken into account how much mass comes from each isotope, so you do not need to divide by 4. All you need to do is multiply and then add these guys all up. Alright? And that is the new way of taking an advantage. Take the percent abundance times the mass. Percent abundance times the mass. Percent abundance times the mass. Add those all together. And that is it. Okay? And the best way to check this is to go to the periodic table and look at the molar mass. You can find the average mass on the periodic table. So I took this clip from a website. And if you notice, here's chromium's average atomic mass, 51.996. So, I need to see, there must be something wrong with my math, because these two numbers should be the same, because I have not discovered anything new right now. I'm just doing math. So I'm going to go back and I'm going to check my math. See if you can find where our mistake was. Alright, if you went back through the calculations, you would have noticed that somehow I must have messed up this calculation, multiplying these two, because when I did it again, I got 43.5213. And then if I add up all those numbers, I get the matching number to chromium, 51.996. So these problems are actually very easy to check, because all you have to do is look at the periodic table and see if you got it right. Alright, so for these ones, as you're learning how to do them, use the periodic table to check and see if you got things right. Alright, so problem 2 is just another exact same replica of what we just did. So pause the video for, however long you need to, and see if you can find the average atomic mass of magnesium. No, really, pause the video and see if you can actually do this, because this is what we're doing in class. Alright, so I multiplied the abundance, percent abundance, but I turned it into a number first, by the mass. Then I took all of those masses, added them up, and I got my average atomic mass. I checked according to the periodic table, and they have 24.305. I have 24.309, which is close enough. My guess is that these masses were a little more accurate than what they put on the periodic table. Alright. As far as sig figs go, when I'm doing sig figs for atomic mass, you always want to look for the sig figs given in the mass. And since we're doing addition, you go out to the farthest place. So in this case, it goes from the tenths to the hundredths, or no, yeah, tenths, hundredths, thousandths, right? That's the thousandths place right here. So I am going to record my number as 24.309 AMU. Box it. Oops. Sorry about that. And now I have my work and my answer. Alright, before class next time, please finish problem 3 and check it with the periodic table. Check your answer with the periodic table. And then try problem 4. Problem 4 is the exact same thing that we have been doing. However, instead of asking for the average atomic mass, it's asking for one of the percent abundances and the mass of that isotope. So it will require you to set up a few equations, and it tests to see if you really understand the math behind taking an average this way. Alright, so give problem 4 your best shot, and I'll see you in class for our snack game lab, which yes, does include food. So make sure you are prepared, otherwise you do not get to participate in that. Thank you very much.